Man, did you see that we are ranked 6th in the AP poll?
Yeah, I think we have a really good chance of making to the playoffs.
It's so crazy how the teams change week to week. It almost just seems random. Hey, Professor, how are you doing?
Pretty good. I hear you talking about a recent win, and I think that's pretty relevant to what we're talking about today, genetic drift.
Yeah, that's like where the population's gene composition changes randomly due to chance events.
Yeah, we watched that in the Panopto pre-lecture.
Yeah, but I don't really know why we need to learn about genetic drift.
I have an interesting example of genetic drift that I think will help you understand it a little bit better. For this example, we'll be looking at a study conducted on jaguars in the upper Parana Atlantic forest in Brazil. This forest was flooded, which caused deforestation in the surrounding area and led to fragmentation and geographical isolation for the jaguars.
How exactly does isolation lead to genetic drift?
Good question. When populations get isolated, such as the case with these jaguars, population size and gene flow decrease. These smaller populations are therefore much more susceptible to changes in allele frequencies, which over time can cause their genes to change significantly from other populations randomly. In this study, tests are conducted on the genomic differences between the different populations of jaguars in the forest. There were multiple clusters of adult jaguars that were identified. The green corridor, 25 to 53 adults, the Morro de Diabo with 9 to 15, and the Ivanhema State Park with 10. Since these population numbers are so low, the jaguars were highly susceptible to genetic drift. The results of these studies show that unique alleles could be observed in all populations except the Morro de Diabo, with the largest and most distant fragment, the green corridor, presenting the largest number of unique alleles. The Morro de Diabo population exhibited reduced genetic variation relative to the other locations, and it was the only area that showed an allele fixed for a microsatellite locus, which is a very highly inherited gene.
Okay, that makes so much sense, but what would happen if species like jaguars stay completely isolated for a long time?
If the species stayed completely isolated for a long time, their genes could eventually become so different that they can no longer interbreed and become different species.
Oh, that makes so much more sense. Thank you.
The biggest takeaway from this study is how genetic drift can lead to the change of frequency of different genes within a population over time due to factors like decreased size and variation. Going back to college football, some things that seem crazy can happen due to randomness, like Indiana being ranked number 5.